Physics Challenge 1, Alternate Current. Alternate current, we have the magnetic field, and the circle of this ring of conductive wire is spinning around in this direction. So the radius is A, and when this is the area A is orthogonal, we have total magnetic flux going through the ring, the BA. But when it's change, say angle theta, then it's gonna be cosine theta, but theta is a time function. It's spinning at the omega. Okay, so A is obviously pi A square. Okay, so the voltage within this ring is BA cos omega t. Now this ring has resistance R and L. Okay, so what's happened is the V equals the Ri, the current inside, plus di dt, and we're going to use that the imaginary number to show. We cover this in other video, I believe, the why imaginary number is important for electrical engineering. That video, you can check it out. It's going to be R plus J omega. The J is imaginary number, it's indicating the phase shift I. Okay, so find the current induced. I is going to be V over R plus J omega C. I'm sorry, this needs a C. So R square plus J omega C square over V R minus J omega C. So that's a current. Okay, and if you plug in V, then the absolute value of I is going to be, let's see, it's asking current induced, so this should be good enough. But if you want to know you can have an absolute value, you can calculate absolute value from this one, or you can calculate the real part or imaginary part. So the real part is the same phase as the I consumption at the resistor, and the imaginary part is the orthogonal, so it doesn't have the power consumption. Okay, so that's the next questions. Power consumption. The power consumption is going to be actually real part of VI in the alternate current. That means V and I can be actually this is going to be VA using imaginary numbers, because there's no, we assume it starts with zero angle. That means there's no phase shift, so it's going to be VA. Okay, so you multiply this together and take the imaginary part, which is this part of the current. Okay, so this is going to be V square, and V square is VA, so V pi A square, and we have R here, over R square plus omega C square. So that's going to be the power consumption. So you know the power consumption is real part of the complex number expression of the voltage and the current. Okay, because where the power is consumed, it's R, and R always stay with the real part. Okay, the C or L alone does not consume the power. Okay, that's the, I think it's the teaching point here. Okay, so I hope you enjoyed this video, and please check out the videos if you like. Subscribe.